Okay, good evening everyone. Let's see if this works and let's see if I can hear myself. I can hear myself indeed, which means I can turn off the music, I can get rid of the headphones. And yeah, so actually I had a little bit of time today, so I decided to attempt one of the things which has been on my mind for a rather long time. And that's the problem of basically in Python, if you have a function, right, it can throw an exception, and sometimes it's documented what exception will it actually throw. And sometimes only some exceptions are documented, and sometimes there's some really deep function somewhere in that function which we are interested in, and it calls a function and this calls another function and so on, right? So we have this call stack, and then really deep in the call stack there might be another function which throws something else. So what I want to figure out today is, can we actually trace what are all the possible exceptions which a function can throw? And I want to do this dynamically, basically, as in, well, semi-dynamically, but I will do it dynamically because that's a little bit easier. Hello everyone, I see there's quite a lot of people in the chat, even though it's Sunday evening, and wow, even a moderator, hey Foxtrot. There's already a remark that it's raising, not throwing in Python. It's accepting, not catching, which is correct, but it's the same thing. It means the same thing, so I will be using probably catching because accepting an exception sounds a little bit weird to me. Raising an exception makes sense, yeah. I'm guessing it's raise all hell, so they decided, hey, that sounds cool, so we are going to raise our exceptions. I don't know, was the true story. Cool, will we be doing this on AST level, or will we be doing this on perhaps bytecode level? I don't know, but something like that. There's another question. Before I start, can you tell me if there is a way to virtualize encrypted system without allowing host to dump memory with encryption key? No. In general, okay, so it's a little bit more complicated. It really depends on what your hardware is capable of, but on most normal hardware with most normal virtual machines, the host system will have access to the encryption key of the virtual machine. There might be architectures where there are things you can do with that, do against that, but usually that is not possible. It's, yeah, I'm guessing if you look at PS5 or modern game consoles, you might find something there where only the CPU has a decryption key and the host doesn't, and there are processes run separately, and every process has its own memory encryption decryption key, and then the host has no idea what it is because it's actually in the CPU. There might be architectures like that, but not on a normal PC, I think. Cool, so let's go with Python then. Okay, so we need something to test this on. I'm going to, I guess, make a virtual environment. I need to check UV for virtual environments, but perhaps not today. Does zero division error count? That's a really good question. So in general, no. I will limit this to a couple of things. There are limitations, which I already am aware of. First of all, yeah, there might be typical runtime errors that, for example, you access a dictionary and that dictionary doesn't have a key which you want to access and you get a key error, or you have a zero division error, as you say on chat. That's a really good remark, by the way. Yeah, these can happen always, I would say, but let's say if this happens, it usually means there's a bug in the function, rather than something which you, as a user of the function, need to catch. It's more oh, if this happens, you probably need to report it to the maintainer. So that's one thing. The other thing, I know that there's going to be a limitation of actually being, well, some functions in CPython are implemented in C, or they can be implemented in another language, and I will not be able to inspect them using the normal ways, and I don't think it makes sense to do, like, really go into these functions. So that will be another limitations. Anytime I hit a function implemented on binary level, on actual machine code level, not bytecode level, yeah, I'm not going to do anything with that. Another complication, but perhaps solvable, is when you raise, you can actually, you don't have to do, okay, let's run Python. When you do raise, you have to put an exception here, right? Like what kind, I don't know, value error, for example. And it throws the exception, or it raises the exception. Okay. Now, if I do a function which is called ASDF and I return a value error object here, which I can do, right? I can just like call this function. I can do raise ASDF, and it still works, of course, because raise actually doesn't take explicitly an exception object. It takes an expression, and this expression can evaluate to many things. So I think I'm going to, by the way, can I do just like value error, or does it have to be, yeah, I can do value error. It does not have to be an object. It can also be a class. So what I'm likely going to do is I'm going to limit what I'm going to catch to either raising a class directly or raising a call to the constructor of a class. So looking at this already, I think using AST is going to be a little bit easier than using bytecode. So let's try to do this on AST level. Yeah, the question which I already addressed, like what are we going to do? There are C bindings, we are not going to do anything, but that's okay. So back to this, I'm actually want to activate my environment, and then I want to install something, pip install. Let's install maybe Flask and maybe Beautiful Soup 4 if I can actually spell it correctly. Okay, and this will give us like some functions or something that we can actually test this on. So now let's do test PY, because that's always the best name for a function. Let's import AST because that's what we are going to need. And let's have a function where we are going to put the starting function. It's called like start, or like the thing being tested, the item being tested, test subject. So this is subject number 1. And subject number 1 is just going to do something with Beautiful Soup perhaps, or with Flask. Flask up. Flask has this like import from Flask, import up. Okay, and up is, what's that? What is it? It's actually a module. Okay. Couldn't I run it? No. I totally don't remember how you use Flask. So how do you use Flask anyway? Python Flask tutorial, because every good live stream starts with opening a random tutorial. Project layout, blah blah blah. I just need like an example. Why don't I have ChatGPT here? Do I have ChatGPT here? No, because I'm not logged in. I need to get, I'm like repeating this a 5th stream in a row. I need to get my AI set up here. Python Flask example. Quick start, thank you. This is way better. Okay, so we import actually Flask, not app. Okay, and then we have this Flask object which we name app. Okay, that's how you use it. Okay, good. So now type app it's a class. Is it? Okay, so I'm guessing app itself is actually an object, and this is a class. Good. So we are going to check, does this object have any interesting, it should have like interesting things which we can call. We can call route, for example. Oh, this is good. So we're going to do like app route, and we are going to check, hey, like this app route, what exceptions can you actually get us? So app route is a bound method, okay, of something, and now it takes as a, I give it something, right? And then it returns a function, decorator. Good. And I'm guessing this decorator, well, obviously the decorator will take another function, so I need to give it a function. And then it will just return me a new version, a decorated version of that function, because that's how decorators work. So this is a weird example. Let's go with a weird example. Can route actually return any exceptions? I don't know. Let's go with another test subject. This is test subject number 2. I do need to import this thing though. So let's go with this thing. Okay. And then I need from beautiful soup, from soup for import, or was it, how do you do it? BS4, tell me it's BS4. Yes, let's go. Okay, and it's just like, okay, so from BS4 import this thing. Then we have beautiful soup. I guess I can do it here as well. Let's run it, I don't know, let's run it with HTML, and then let's run it with, we have to specify the format here, perfect, and we get a soup back, a soup even. So, soup. Okay, these are our test subjects, basically. Good. So now, what do? We make a function which is called find all exceptions, which gets another function. And now what we are going to do is we are going to, oh, because, wait, that's a little bit problematic, because if I'm going for AST of a function, it will want that function to be actually in a different, I'll have to go with bytecode, won't I? Because if it's not bytecode, if it's just AST, then I need this as text. I don't think I can get, if it's already compiled, I cannot get, that's okay. So let's actually do it like this. Subject 1 and subject 2. Alright, now that's okay. Let's go with this, and let's go with, Now here's the problem. If I go with this, I'm going to have to write a loader, and I'm not fully sure I want to write a loader, which makes me go back actually to the bytecode idea. Maybe bytecode will be easier actually than AST, because for AST what I would have to do, right, every time I get, I don't know, like for example I get this beautiful soup, right, I need to write a loader. I need to make sure that this thing is actually imported, which means I need to find the BS4 in my environment, and then I need to load it, which is fine until you figure out that in Python there are weird loaders, and we would have to handle weird loaders as well, which I don't really want to do. So perhaps what I'm going to do is I am going after all to go with bytecode level. This will introduce some complications, but it will solve at least some other issues. And this is just like, I'm trying to just like figure out if this is even doable in a decent way. So instead of AST, what we need is we need this. This as in disassembler. Okay, now I obviously don't remember Python this. We did use it a few days ago on another live stream. Was it? I'm going to open the code from the previous live stream which we did, this compiler, right? And this is, oh, let's open actually the normal one, not the code golfed one. How did I start here? So I had this, and I just, okay, this bytecode C, and I just give it the compilation object, but I can give it a function as well, so this is fine. Okay, good. So I do this bytecode func, and I have something. Let's do print. Let's assume I'm going to return a list here. A set, well, it's going to be a set, right? A set of exceptions, I'm guessing. So let's go with a set of exceptions. That's not a set, that's a dictionary. This is a set. Final exception subject 1. Good, and then subject 2, and I'm guessing we need something like this. I see there are like some comments and questions on the chat. I will look there in a second. I just wanted to bootstrap this a little bit. So let's run Python test py. Okay, something works, which is not bad. Now, let me look at the chat. Oh, you're suggesting that like a function should just raise... Okay, let's do subject 0. That's a good idea. That's a good idea, Johnny, that we should have something which just does raise and like some kind of exception, value error. Now, just to be certain, I care about value error. I don't care about whatever arguments value error is going to return. And this is like just a basic, really basic test case, which will probably be working even before every other test case for the obvious reason of we do not need yet recursion of that. So that's one thing. Okay, let's do another thing. Let's do this, because I actually would like to see what's going on there on the bytecode level. Okay, so quick look at the chat. Aren't exceptions by default limited to only those known to the coder and everything unexpected will crash the executable? That's a question from Jan. It's so it's like this. Not really. Well, no. What you said is true, but as a user of a function, as a programmer, right, a user of a function, my issue is that I would like to catch all the exceptions which the function can throw, but like if it's not documented, then how can I learn about it? And what I'm trying to solve here is like that learning about it part. So I don't want my application to crash because like some random exception is thrown, which is just like somebody forgot to add it in the documentation. So will I be back to scheduled streaming rather than just randomly? For now, it's going to be random because I actually do quite a lot of live streams, but most of them are not on my channel, and most of them are part of like some workshops. Some of them are paid workshops, so I like my calendar is really messy right now, and it's hard to schedule something. So other than that, I just decided to do random streams whenever I have a little bit of time. Okay, so, okay, the question, there's a really good question, whether load global is all I need. For example, here, right, like we have this load global. Like one could even argue that you just need to look into the, so it's like this, every function, right, has okay, let's maybe do it in Python because I need to check the naming anyway. So let's make a function, let's call it func. Yeah, sorry, my typing is terrible. Okay, but that's a bad idea. Let's do raise value error. Let's do it like this. I can run it. Now, this function, if you look at it, it has something called code. Function by itself has type of function, but this code thing has type of code. Now, this code object, which is a really basic CPython object, has something called co-consts, and that's a table of all constants which are being used by this function. So that's one, but load global actually uses names. So what we care about is names. This is the names of globals. Constants are constants, like literals, right? Like 27, none, false, and so on. Names, however, are what the function knows is it's not a local value, like local variable, but it's still being used. So it's either going to be something defined by a parent function, and by parent I mean when you have functions, nested functions, basically, or it's going to be something which exists in the global namespace. So one thing you could argue is like, well, if you have func, right, you already have globals for it, like the globals table to whatever it has access, including built-ins. And you have these names, and you can go like take all the things from the names, and you can go through the globals, and you can go through the built-ins, and you can say, hey, well, there's actually value error is actually a type, or rather, it inherits from exception, so it is an exception. On the flip side, you don't really know if that value error is used just because somebody like has written print value error. Well, that's kind of weird, right? But you don't know if it's risen, someone has written raise value error somewhere, or if someone is catching that exception. So maybe somebody is catching value error. And this is also another thing which we might have to handle, is when a function has like a sub-function, but that sub-function is actually in a try-catch block. Then the question would be what exceptions are being caught. And parsing that on AST level would be way better, way easier, because the try-catch in bytecode looks like a mess, if I remember correctly. Let's actually make another test subject then. Let's call it test subject. You know what, I'm going to change this to 2 and 3, and this one's going to be 1, and this one's going to have like some sub-function which I called func, and this sub-function is going to do a raise, but it's going to actually like, it has a parameter. If x is 1, it's going to raise value error, otherwise it's going to raise key error, because why not? And here we do a try func of 1, except, or maybe it can take a parameter, right? Why not? Except the value error. So what I would like our code to do here is I would like it to just return, for this example, just return key error, because value error is already handled here. Which makes this even a little bit more complicated. Let's do 3, let's run it. Okay, so we have an exception table, which is already interesting. Something something that might actually make it easier for us, I think. So let's look here. We have raise var args. Okay, this is good. How many, actually, I don't know. Raise, how many different ways to raise an exception there are? Raise var args is one of them, but are there other? No, I think there's only raise, like in the... Again, I see only raise as an instruction. Well, re-raise, but re-raise is like, we don't care about it because that's a dynamic raising of an exception, we don't care. As in, like, it sees what exception is on the stack and it raises it again. Yes, now I'm a little bit more back to normal streaming, that's true. Okay, so here, what's this? Raise exception instance or type at stack, okay, but understand. This is re-raise, I guess. Why is there a separate opcode for that? And 2 is raise from what? I don't get it. Raise exception instance of type at stack -2 with cause being in stack -1. How exactly does that work? Okay, Python raise. How does this instruction work? No, why is v3 schools even here? Even in my results. Okay, raising exceptions. I do understand that. Oh, shorthand for, so it actually makes the object. It doesn't raise the... That's interesting. I thought it would actually like return a flag. a flag, a class. But apparently it makes an object. Okay. So what exactly is a cause? Okay, I don't think it's well documented. Maybe it's obvious when we start looking at it. So let's look at it. What's happening here? We put value error on the, well, this is obvious, right? Like we put value error, we put a parameter, and then we call value error. This is what we are calling because it's a constructor. So what we get from here is we do get, this is going to be a pain, isn't it? AST would be so much easier. Do we need the compiler to put it in the AST first? But okay, and then we do arrays. Note that there is no return. Okay, that's interesting. Let's look at the second example. So in the second example, what we do is we have this exception table. From 4 to 24, we are 0. I'm not sure what that means. And then we have 28 to 44, 28 push exception into the, okay. And then from 50 to 50, that's the re-raise. Okay, so how does the exception table work? How do I know that we get a value error? Oh, here we get an check exception match. Check whether the exception matches, which checks whether whatever we have on the exception stack actually matches, is a descendant of this class, or is actually of the type of this class. Yeah, it's kind of like a choice between whether we go for trying to untangle bytecode in this case and emulate it maybe to a certain extent, or whether we deal with the loaders. But I think I don't want to really deal with the loaders. Okay, this is returned const, so this is pretty interesting. Like the function itself is really short, and then we get the exception. What's 52? How do we even get to 52? Okay. How does this exception table work in Python? Python code object, or code type maybe. This is what we care about. Okay, exception table. Yes, exactly. What's an exception table? How do we get to that exception table, and what is there? Let's take a look. Let's do, actually here, let's do a breakpoint. And let's run the code again. And now let's, once we have subject 1 defined, we have it defined, right? So we can look at the code object and we can, what's the name of the exception table again? It's exception table. Okay, co-exception table. Oh, hello, binary code. That's interesting. I actually was expecting a list or something like that. I was not expecting this. And we kind of know, okay, we have to parse this a little bit because this might be important and I need to understand what's going on here. I'm guessing, or rather starting to guess that, hey, this is going to take more time than I imagined. So this is really going to be just an exploratory stream in that case, I see. Okay, and this is what it parses to. How do we get from here to here? Sorry, can you give me that as like hexadecimal? Let's use it with a separator of a space. It's a little bit more readable then. Okay. I absolutely have no idea how they arrive from this to this. 1A, that's what, 26? There's no 26 as a constant here. There's 9. There's no 9 as a constant here. Am I looking at the right function? It is the right function, right? Subject 1. Yes, it is. I'm starting to lean into AST. Let me take a look at the chat. Why not look into C Python source code to look how raise instructions implemented? I don't think I care that much, but we'll figure it out. If we figure out solution to discover undocumented exceptions in Python functions, will it be the same method for Rust and other languages, or we have to find unique solutions for them? A question from Jan. Actually, it's totally different. Like, every language does it differently, and even within one language, like C++, for example, every compiler or even every platform can do it a little bit differently. For example, on Windows, if you use GCC from the mingv package, then you have to choose which exception scheme you use. And in C++, is like, funny enough, but for example, the default implementation on Linux has a pretty much it has like a virtual machine of its own with its own opcodes and so on. There were some CTF tasks in the past for that, and that was pretty funny. If you speak Polish, actually, I've written about it in, I don't know, like 5 years ago, maybe 7 years ago in the Programista magazine. It was called like Exceptions from the Kitchen Side, like Wyjątki od Kuchni or something like that, if you're interested. Anyway, so yeah, it's like totally different in every language. Especially that Python gives you a lot of inspectability into the language, into what's going on. Like you have AST, you have bytecode, you can look into these like code objects and so on. Other languages in general don't give you that much information about what's going on there. Okay, no, like really, what's up with this like exception table thing? Because it's weird. Exception. Okay, it says it's an object. Well, I believe it's an object. But what format is like of it? Python 3 exception table. That's not what I wanted. Exception table format. A binary format, let's add maybe. Okay, it's not really well described here. I guess we could look in the disassembler source code. I'm guessing there's like the top bit here and the top bit here is going to be just a flag. Assuming so, we would have from 2. Let's look at. Assuming it's just a flag, yeah, what do we get? But it's 4. What's going on here? Okay, this is the byte number, right? Yeah, this is the line number, this is the byte number inside the code. Why is it over by 2? Then 24, that's what? That's 1. I mean hexadecimal, that's 1/8. So, yeah, I have no idea. That's weird. We would have to look probably at the implementation, which makes me really want to go back to revisit the idea of, hey, maybe we actually want AST and deal with loaders. So let's go back to AST and think if we can deal with loaders in that case. But in that case, we probably need to grab... Okay, so let's put this, all the subjects. Somebody suggested that on the chat already, to put this in a different file. So let's like tests.py. And these are our test subjects. Then we put them here. And that way we actually can either just import them and put them in the disassembler, or we can No, this is actually fine. We can, yeah, again, we can either import them or we can just open that file as a text file, have AST compile it. Here should be 3, by the way, that's a mistake, but that's okay. Here, let's do this, and let's go back to the IST idea. That might be actually way easier to do. Okay, Python AST. Maybe exceptions is not in the code. Nah, I'm pretty sure this, like, there's some magical way to interpret this array to get this. I'm pretty sure these are identical, just like would require a little bit more thinking how this actually works. There might be some kind of space optimization. It's a good question. I'll look into it maybe off stream. AST won't find all exceptions. So if bytecode finds... No, all exceptions in AST should be visible in bytecode. Like, these should be the same thing. AST and bytecode are pretty close to each other in terms of what information do they possess. AST obviously also has the structure, which the bytecode does not. Okay, so back to AST. Hey, we did use AST in that widget compiler, right? Yeah, but that was unparse. We care about AST parse, yeah. So yeah, we just copy this because why not? Okay, so let's open tests.py. Let's read it, and we have it in the source code. Then we need to pass the source code and the function name to find all exceptions. So we can do, we get a tree from this, this is good. Here we just need to pass the source code in all these cases. Okay. And now what we need to do is we need to go, I guess, for... So, well, what we get from T here is we get a module. So T should be the type of module here. Let's run it. Yeah, it's AST module. And module has a body, if I remember correctly, which is a list of statements. Yeah, it's a list of statements, and we have function definitions there. So what we need to do basically here is just like for a statement in T body, find me a statement which is of if type of statement is function definition, AST function definition. Yeah, it's function definition. Then we go here and just print it, and then we'll have to figure out what was the... I think it was just .name, right? Okay, I apparently cannot code because here, where we go. Okay, good. Yeah, so we got all the function def... Why is set? Oh no, it's the... Okay, I trolled myself. This is this print. Okay, so it has like 4 functions, right? And this is function definition, and we get the name from it. And if this name is actually whatever we are looking for, like func, then this is what we want to handle. So if this is what we want to handle, we can do return, and we need like some exception worker, find all exceptions worker function, which takes, it doesn't take the source anymore, it takes the, what does it take? We'll give it a function statement, right? So like a func statement. And here let's just return a set here. And let's call this find exception, we give it that statement. And here what we are going to do is we are going to, oh, you guessed it, raise value error exception function not found. not found. Now I don't like a couple of things here. I don't like that this is function and not function name. So there we go. Okay, now we should be, this should be good. We are returning a set, which is from here, good. So we can print, let's just print for a moment the actual source code. If you're wondering what unparse does, it's basically like a decompiler for the tree. Sorry, what was that? Function statement, of course. There we go. Yeah, so we got like, as you can see, it's formatted a little bit different, right? Like 4 spaces instead of two, which I use, and so on. This is because it's not it doesn't print the source code. It actually goes through the tree and reassembles it as Python source code. Here, I was supposed to rename it. Thank you very much, Johnny. Okay. Okay, so there's a good question. How does AST parse resolve nested modules? It doesn't, as in, from AST perspective, as we could see here, like what AST does is when you compile something, right? There's like a couple of phases of the compilation. In first phase, you basically tokenize everything, as in this is a token, then there's a space, which is a token separator, and then you have another token, and another space, another token, and so on. And for now, these are like all tokens, and then in the next phase, you kind of try to figure out what each token represents in a logical sense. For example, well, this token combined with this is actually a string literal. This is actually an integer constant. And this is actually a function name, right? So you assign name to the tokens. And then when you start putting this, then the next step is to create a list of trees for every code compilation unit. When a code compilation unit, for example, is the global module code, then a function code is also a code compilation unit, similar to like a class body, for example, in Python, right? As such, from AST perspective, this isn't doing anything. It's just like a node in the tree, or rather a statement on the list, which represents an import from import statement. So it doesn't do anything by itself. It's just on the list, as we can see here. It's just on the list. That's it. Nothing happened. It didn't load any file. It didn't do anything. It didn't look for that library. It doesn't care at all if the library even exists. Which is why I said that, yeah, like if we go the AST way, we will have to handle the loaders, unfortunately. Okay, would this what I'm doing work for PYC? No. It wouldn't, because AST is, again, when you have, let's go like this. First is tokenizing, then is parsing, then is like making AST tree. Or maybe let's just call it AST tree is like abstract syntax tree, which is actually, this isn't fully true. It's like a mix of lists and trees. And then we have, let's call it like Python assembly thingy / bytecode. I don't think Python actually represents at any point the program as assembly, but I think it just goes straight to bytecode. So it like compiles from abstract syntax tree into bytecode. From here, it's pretty easy to go back to source code. You have source code here. But from bytecode, it's a little bit harder. You need, in Python, okay, in Python it's still somewhat easy, but it's not that easy to go back to source code. And to make abstract syntax tree is easy to do it from source code. It's not really easy to do it from bytecode. As in, if something is above it, above abstract syntax tree, it's easy to make an AST from it. If it's below, it's much harder. And in PYC files, you actually have Python bytecode. Like a PYC file is technically a really short header. Like I think they're like 12 to 20 bytes of a header. And then you have a marshaled object. Marshal is like one of the Python serialization algorithms. And then what is marshaled actually is these like code objects, which we already played with. So yeah, going from below to a little bit higher, it's harder. You would have to write the compiler or like get the compiler, which is doable in Python. It's not that hard with Python. It's way harder with machine code. Why? Because machine code is much more complex. There are way more instructions in machine code than there are in Python. Python is just a stack machine. CPython rather is just a stack machine, while normal computers, they're like really complex machines which like have registers, have a memory, have also the stack which is part of a memory, but it's much more complex. So yeah, not as easy to do it. Okay, so Luke says that actually the exception table can be parsed with a... I'm actually going to check that because that sounds really interesting. So let's actually copy paste this code. Function is here. Yeah, let's grab these two. I actually didn't need to copy function at all, because unless I execute it, it won't cause an error. So let's do this on subject 1. Okay, and we have this exception table. Now, what Luke has said is that we have in this a function which is called parse exception table. Okay, which we can call, I'm guessing, with a function, subject1. No, we have to call it with a code object. Okay. And then we get exception table entry, start and target depth last I. Not sure what last I is, last instruction. Might be last instruction. So okay, so we do have a function which does it, which is nice, which is really good. And I'm going to actually write this down because this might be important later. But let's continue with AST for now. Okay, so going back to AST, what we have is, well, we have this, right? Which is every block of code in Python is a list of statements. A statement is a try, block, arrays. Like this is actually technically an expression, but an expression by itself is also a statement. And this is, for example, an assign statement. So we have this list, like every block in a function is a list of statements. Some statements are simple, basic statements, like this one, which I have marked, and some are complex. A complex statement is like an if, for example, a for loop, and so on. So it has like a sub-block of code, which is like one or more, which is why I said this is a tree, because, well, you have, that's one of the reasons it's a tree, because you have nodes on the list which actually have lists of statements of their own. That's one reason. The other reason it's a tree is because expressions are also trees. For example, well, this isn't really visible here, but if you would have a mathematical operation, like algebraic operation, like 1 + 2 times x, that would be a really nice abstract syntax tree. Okay. Surely someone already made an implementation of standard Python module loader algorithm. So one thing which I have to add is that actually there are like multiple of them, as in multiple loaders in Python. One is the default system one. For example, when I do import OS, this uses the default system library loader for Python. And another loader is the one, for example, which looks in the, what is it called, like site directory which Linux, my Ubuntu for example, uses to store system-wide Python libraries, or maybe rather user-installed Python libraries. And then there's another loader, for example, which looks in this current directory for modules. So there's a way, let's go to Python import. The import system, yeah, exactly. And there's like sys.something. Sysmodules shows you the okay, this is not yet what I'm looking for. But it's like surprisingly complex, I would say. So sysmodule shows you all the system modules, which is the first thing actually where Python looks for a module. Now, if a module is not found there, then it goes to where does it go to? There is like somewhere there's a table of loaders, and is it path hooks or metapath? Sys metapath, is that it? Yeah, it is. Here, there we go. This is basically like loaders which are then in this order executed. So built-in importer, I'm guessing that's this one. Then we have frozen importer, which I'm not fully sure what that is. Frozen is usually used for bundling, I think. And pathfinder is, I'm guessing, when it's like actually using the environment variable which tells you where it might be, where modules might be located. And I'm pretty sure on a different project which I used, it actually was a little bit different. You know what? I'm going to run another console without activated environment, and let's see if it matches. I'm quite curious. Sys, what was it? Metapath? Yeah, here for example we have this utils meta finder, which looks in the I think this is like where the operating system installs the modules. I'm not fully sure about how this works. I did dig into this a little bit, but I dug into this like a couple of years ago, so it's like outdated. Can I alter this? Yeah, I can absolutely alter this. I can like do other stuff here, and I think I can even use this, as in I can actually grab one of these finders, and I can tell it, hey, like, could you, like 0 for example, and I'm pretty sure I can tell it to find me where something is. Let's try, let's run this one, and let's do get source of sys. But it's not great. Get code. Okay, this doesn't work. Find spec. Exec module, create module, load module. OS. Okay, so at least this works. Let's try get source again. OS is not a built-in module. Really, it's not. Now, why did this work then? We are confused. Help, get source. Full name. Return none, as built-in modules do not have source code. Okay, I'm not going to get very far with this one, I'm guessing. So let's try with a different one. Let's go with 2, I'm guessing. 2 is the frozen. No, I want to go with 3. No, it's okay, it's a pathfinder. It's probably the one I want. So load module BS4. It doesn't have a load module. What does it have? Find spec. Okay, what's a find spec then? Try to find a spec for a full name. Okay, So what happens if I call you with BS4? Okay, it does return something, a module specification. The name is BS4 and the origin is here. Maybe we can just, yeah, maybe we can just use these loaders instead of implementing ourselves. Maybe we can just use them. Now I figured that actually when an exception is thrown, something has to tell Python to tell like in what line of a module was the... No, but that's in the... No, okay. So it's like this. When an exception is thrown, then Python has to show part of a source code, if source code is available, of course, for where the exception was thrown. And I'm guessing loaders are actually being used to find that source code, which means we can use them as well. Okay, so AST is probably the right choice here. Good. So there's another question, can't we use just like import lib, import module? So we, oh, and there's a .file. Import lib. So, okay, two things. The problem with import module is that it actually imports the module. And we probably don't want it to import the module. What we want to do is we want to open the file and parse it, not necessarily execute it. This utils maybe wheels, maybe. Yeah, okay, cool. But that's some progress. Now let me mark this here actually, that we can probably like use loaders from here. But let's continue going through the statement. So I don't remember function statement. Could you tell me your function statement, what it has? Like the node function statement has quite a lot of attributes or fields, if you will. As we can see here, it has, for example, a name we are already using. Body is what we care about. Okay. I think we care only about body. Like there's like stuff like decorator list. Maybe we care about decorator list as well. Okay, let's assume we also... Arguments are pretty funny. Pretty complicated as well. So let's go with body, and we might care about decorator list for later on. So to do function decorator list. But for now, body. So body of a function, as we saw here, by the way, because like a module also has a body, is just a list of statements inside that function. So if we do for statement inside function statement body, let's move this here, move this here. Let's print that statement. Okay. Okay, we have raise, try. Why are we printing only one statement? Does every function which we... Oh, because, yeah, every function, I'm guessing, has only one statement. And you might be like, wait. Here we have 4 statements, right? No. Well, yes and no. It has one complex statement, and this is what we get here, this try here. But this complex statement then has... And we'll have to, like, see, hey, is this try, is this if, is this for, is this while, and handle it each individually, I would say. Okay, so let's start with raise, because we care most about raise. So let's start with raise. We check if something if. Is a statement a raise thing? Is it... Okay, one more thing which I actually am going to change. Here, we pass it a function statement. But that's okay, but we don't want to do the work here. We want to do something like process statement list. And we give it a statement list. I'm going to tell you why in a second, but basically it's because we will be processing mostly lists of statements rather than individual statements. Good. So this is actually going to go there. So let's leave this here. And here what we are going to do is we are just going to do process statement list. Let's assume we are actually going to give it an exception set. It's going to be a little bit more complicated probably. So I'm not passing the exception, like I'm not passing the output container yet. For now what I'm going to do is I'm going to give the list here, and this means that these two instructions I'm going to move them here, and here I have a statement list to operate on. Statement list, good. Now, if this instance, we probably should do it like correctly. Now, statement of raise, we want to print it. Okay, and only this was printed for the first function, which makes a lot of sense. Let's actually, you know what, do... not this, maybe do this. Okay. So yeah, so we have here the raise statement. Now the raise object, I honestly have... well, it takes an expression, right? So let's see what's there. What fields are there. A raise statement has just x. And I'm guessing this x is going to be an expression tree. So let's do statement.x, and we get a call object. Because it's a tree, right? So there are like nodes, and the one node is going to be obviously a call. And the call is like, the question is like, what is the call to? And that's going to be also an expression, by the way. And another question is going to be, what are the arguments of the call? And we do not care about the arguments. What we care about is, what is it a call for? Now here's the problem. Like if we have raise value error, this is pretty easy. If we have something like raise determine what exception to throw function, which returns you an exception object, exception compatible object, and then we have a problem. But okay, there will be actually a couple of more problems. But okay, let's continue from here. So we know, let's assume that for now we are only handling really simple cases. So we assert that statement exception is actually the type of this instance is actually an AST call. We are going to assume that, but it's a call. Okay. And if it's a call, then let's just print this call. So x and directory, we get, okay, so if it's a call, we get arguments, but what do we call a function? We call a function. A function is an expression, it's not a constant name. So as such, we should get func. And it says that this, sorry, what does it say? Oh, we do a dir. I don't do dir for a second. We get a name, which is good. So this is another thing which we are going to assert. Is instanced, otherwise like unsupported. Not implemented maybe. This instance. Okay, statement exec function is actually a name. Otherwise is like not implemented. So we get the name, and the name should have something which is called name, I'm guessing. And this doesn't have name. Name doesn't have name. Does it have text? What does it have? Okay, I have no idea. Okay, directory. What's the... Why wouldn't you name the field of a name? It's called ID. Oh, of course. How silly of me. Okay, and we get value error. Okay, good. Now, one more thing which I'm curious about actually is at what point, because we know we can do this, right? And we know, we read in the documentation that this is the same thing as like calling it without any arguments. Is it visible already in the AST tree or perhaps not? No, it's not. We get not implemented. I'm actually curious, what is it in that case? So it's not a call, it's going to be an... What is it? What are you? Print statement, exception, and... Okay, yeah, what are you? It's probably a name, right? Yeah, it is a name. So I guess we are like actually supporting two things. The easier one is if this instance, if what we have in raise is this, so that's AST name, then we already have our answer, like this is what kind of exception it is. So how do we report this exception? It's a good question. Let's just do exceptions, and it's going to be a set. So we do exceptions add AXC ID. And I don't think we have to do anything else here, so we just continue. Otherwise, if it's actually a call, exception AST call. So here what we are handling is raise like this. For example, raise value error. Now, here's the problem. In this case, it has to be an exception, otherwise it's an error, right? In this case, it doesn't, but it probably is. So what I'm going to do now is I'm just going to report it, I think. Here is not... Yeah, it's muscle memory. Like ECX is like... That's the register, right? Like 32-bit register on x86, it's muscle memory. Thank you for pointing that out. But if there are two statements, I mean, for example, two try-catch blocks, then that's okay, right? This is a list of statements, so we would first process one and then process the other. Okay, so this instance, it's a call. Then if it's a call, we assume it's a name. It doesn't have to be a name, right? Like another example is it can be something like this. Raise list, for example, value error, and then we select the 0th element and then we call that. This is also okay, unfortunately, yes, and we make a list, we actually evaluate it, get the first index, and then we call it. And then, yeah, this is, I'm not going to implement it now, so what I'm going to do instead is, if it's a call, then we check if it's a name. And if it's not a name, then we say not implemented. And we do, let's just add it to exceptions for now. This isn't like, this might not be an exception name. It can be an exception selector. But let's add it anyway, so it's this thing. Good, and then we continue. Okay, so we are processing raise, which is the most important one for us. Then we get exceptions. Where are we actually calling this function? We are okay, so here we need the set. So exceptions, it's a set for us, and we pass it here. And then we here return it. Okay. So we got value error here, which is correct. Here we are still not getting anything, even though func is actually returning something. So what we want to do is now we want to go deeper into a given function. The problem is that the function might or might not be available in this namespace, and we actually have to... Here's another problem, because apparently we are like going into a rabbit hole. What I'm doing now is the moment in AST3 I get a find a function, right? I'm immediately processing that function. So for example, here I find this function and I'm immediately processing it. Now, this function is calling func. The problem with this is that this func function, it doesn't have to be here. It can be here. Why can it be here? Because this func, this is going to be resolved only at runtime when this is being called. So func itself is defined later in the code, but earlier in the runtime, and this is the only thing that matters. As in, when this code executes, right, then Python does the import, then it defines this function, defines this function, but only when we call this function, it actually tries to look up this function. It's not like this in all languages. In Python, it's like sort of like I described, which kind of means we have to, our AST code, processing code, which finds immediately this function and starts processing it, because we want to, for example, process subject 1, it didn't even get to the definition of func, which means from the perspective of our AST code, this func doesn't exist. Which means here we actually need to add some kind of whole module processing. So do something like process the whole module, which would give us, I'm guessing, a list of functions. And this still isn't ideal but it might be a little bit better. Because, for example, we have this. So we have a function called func, right? And this is what we can easily detect. What is problematic if someone does this, and people do this from time to time. This is an assignment statement which just makes an alias for the function, and we will not catch it if we catch only function statements, function definition statements. Yeah, okay. So let's do process module perhaps, and it gets a module statement. And what it returns is, I'm guessing it's going to return a dictionary. A dictionary of the namespace. So ns is going to be a dictionary, and we are returning ns. And what we are doing here is we are going to basically do this. If it's a function definition, then we put it in the namespace. So namespace, I'm going to get one funny if. What's the name of the function? I'm sorry, statement name. So func name is this. If func name is already in namespace, then like print hook weird func name is already in namespace. I'm not going to add anything more here, but that's okay. And now in namespace for the function name, I'm just going to give it this function statement. Okay, good. So now we process the module. Here, we process the module T, and we get the global namespace for the module, so M, let's call it M. And now we do M of func name, and this is what we are going to process. Find all exception worker, and we give it this, but what we also have to give it is we have to give it the namespace, I guess, and it's going to get even more complicated later on. So for now, I'm just going to give it the namespace. So let's remove this. Here we already are going to get a key error here if that function doesn't exist. This means that we are getting a namespace here, and we should pass this namespace as well here. So note that the namespace will obviously change if we switch to a different module. Good luck handling call functions. Yeah, there are like so many, it's a rabbit hole, right? There are like so many exceptions to what seems to be a simple problem. It's just amazing. Okay, so good. We do continue, and here is like something else. So we do assert false, not implemented for now. Like if raise does anything else than a name or a function call, yeah, just let me know. If is instance statement, and we are doing, if we are doing a call, let's handle that for first. So AST call. Then we have to figure out if we have the function which is called in this namespace. So if when we are calling something, we have this AST name thing, right? But it doesn't have to be. So let's assert for now that is instance statement function. Oh, this is a call, right? So yeah, so function is actually AST name. Otherwise not implemented. So this means that we are like checking we support only something like print blah blah blah. We don't support like something like this, for example. Okay, so we have a call now. This function name, so function name in this case is statement function ID. If function name is in a namespace, then what we can do is we can basically go to do the same as we do here, right? Just do this. But we have a statement, this is statement, yeah. And we call it with exceptions, and we call it with this. Otherwise, if it's not in the namespace, so else, what we do then is we say, like, warning, unknown function. Unknown function, and then we give a name of a function, just func name. Okay, now this won't do anything new. Apart from throwing this exception, of course, because we have T. What's wrong with T? It's module statement, not T here. There we go. Okay, function statement, I meant function name, of course, yes. I'm guessing someone on chat already has written that I have a different, like a variable name there, but that's fine. Okay, so this didn't do anything new because we didn't handle try except. So now let's add try except handling. Here we do continue. Yes, these could have been elifs. Is instance statement. I'm guessing that's going to be called try. I think it's try. Well, we'll see in a moment, I guess. Print dir. Okay. What is it? Wait, why does it return none to me? What did I do? This one already worked, right? So it should return. Okay, because we are not doing this return here. Yeah, that's it. Okay. Okay, so yeah, we have body of try. We have to process the body. We have to process or else? What's an or else of a try? Or handlers. Oh, handlers are going to be funny, aren't they? Let's see what we have in handlers. I'm quite curious. So print, tell me what we have. Statement handlers. So we have an exception handler thingy, which I have no idea what it is. I'm guessing it's going to be like a... Why is it a list? What's going on? Okay. Handle, handlers, or else. Finally. In a moment, first we have to handle the body. And to handle the body, we are going to just call this. So we call this, we give it the same exceptions, and we give it a statement body. So we do a recursive call. Okay, and then we do continue. So now things should work. Oh, they don't. Because now we should actually go into this function here, and we are not going into that function for whatever reason. Why are we not going into that function? So let's do this. Let's do here, when we are processing something, right? Let's do some asterisks, then a space, and then do print AST ampersand. And then we can give it a statement list, actually. It works with lists as well. Okay, good. So here we go into try, and then we get func. Why doesn't func get... Why don't we... This is it, right? Why don't we get here? Are we getting here? We are not getting here. Why aren't we getting there? We're getting here. Like, I expect that this would actually... No, we are not. Why is that? Not I'm going to print the type of statement always. I have some stupid mistake, don't I? Oh, because it's an expression of a call, yeah. I said that a single call is an expression, that's okay. How do we deal with that? That's weird. Why do we even have an expression as a statement type? Okay. If this instance, I kind of understand why we have it, but I can complain about it. Okay. So if expression, then, for example, like, so an expression might be like print ASDF. It can be 1 + 2. You can have that as expression. Almost always expressions, I guess, like our function calls. So, like, why wouldn't it be? Maybe you know, a comment can be an expression as well. So, okay, so this is an expression. I have no idea what do we have as an expression. What fields does it have? We can figure that out in a moment. Here, an expression actually has a value. Value, okay. Statement, value. Why isn't a value? That's a weird name for an expression. And it's a called object. Okay, good. In our case, it's a call object. So, for the value of an expression is... I'm just going to go more recursively, like more recursive. Yeah, let's just do this. Like, I don't think there's much sense of doing anything more here. This kind of messes it with... Okay, so one mistake I'm doing, right? Is I'm saying I'm processing statements here, but I am already processing call. Call isn't a statement, call is an expression. But, so, yeah, maybe that's okay. Okay, call object has no attribute body. That is actually correct. It does not. Why does it? That's okay, like it doesn't. Why do you actually care that it should have here body now? So, no, I know, because what I need to do is I need to do here. That's ns of function name. There we go. So we actually grab that function. And we are getting into not implemented. Let's see what's going on here. So we actually go here, which is good. Oh, and then we don't support if. So if else is the next thing which we should support. So let's go and do that. If is instance statement AST, and that's, I think if, just if. And I don't know what if is, so let's do this and continue. So for an if, what we get is we get a body, we get an or else, and is that it? And a test. So a test is an expression, as we know. Is this it? What about else if? How does or else actually work? I don't know how or else works. Print statement or else. Is this going to be... It should be a list, right? So we have... Yeah, this makes sense. What about elif? How is elif parsed in this case? Like if I do here, right? Like elif x equals 2 and I raise file not found error. What does that do with our if? Oh, it says it's another if object. Oh, so AST actually already deals with the elif syntax sugar. Good. Very good. That makes it really easy. So, we have to do, in this case, like a lot of things now are going to be just recursive calls. Okay, so test is first thing. Test is, you know, the condition. And it's going to be an expression, so that's fine. Then the other thing is the body, and the L, then we have the or else. Now body and or else are actually lists. Okay, good. So, yes, this means it worked. It actually grabbed that file not found, key error and value error are passable exceptions to be thrown inside a function which is called inside the function. So we already support this. Now we get some funny problems here for the route. Because, yeah, I'm guessing okay, it's a call, but the call is actually on this expression. And this expression is not a name. Well, true, it is not a name. And this already brings us to another problem, is that in non-runtime situation right now, we actually have no idea what app is. We can figure out its type, probably, but maybe not. And yeah, and this is a little bit more problematic to solve. Like, how do I how do I handle methods? And methods are hard to handle statically because assume I have a, like, I don't know the object type, and I'm not always able to figure out the object type, but the method is called on. At times I can, at times I cannot. And this is a pretty common thing to do, right? Which makes that, like, this whole AST parsing is not enough. It would have to be done at runtime, so that we have actual access to the actual values. But that's not even runtime, that's like dynamic, which, okay, runtime and dynamic is the same, but what I was going after actually is that we would have to run the code to get the proper values. So it's a complicated problem. It's a really complicated problem. I think I'm going to actually like end it here because I need to think a little bit more about it if this is actually doable to the extent that I can be certain that it works. And I don't think the answer is yes. It might be no. So okay, let's add that. Let's like finish with that. We got it working to two simple cases. Like two simple cases are working, and we could in the same way implement for statements, while statements, and so on and so forth. What I've also learned is that elif is actually handled at the AST parser level, which I didn't expect, honestly, I'm not gonna lie. So that's pretty interesting. Let's look at the chat then. If there are any comments on this. Okay, should I be tracking function calls? Yes, I should be tracking, maybe not function calls, that's a little bit less important. What I should be tracking is try except blocks. Because if, like here, right, like what I already mentioned, if we actually throw value error here, sorry, when we throw value error here, but it's actually caught here, that means it's not really, it doesn't surface to our level unless, to the user of a subject one level, unless value error exception handler would do a re-raise. Which, yeah, like just, you know, writing raise here would actually make it re-throw, continue throwing the last exception. So that's solvable. That's not a huge issue, but I should be still tracking try except blocks. Okay, but then if you do run code, you're also missing out on potential errors that would only occur if you have other values. That's a comment from Johnny. It is spot on. I think it would have to be a mix of trying to get some, like get values dynamically, at the same time doing the whole AST processing as I'm doing. It should be like an addition to, augmentation to it, if you will. Think about using something like Pyrite. What's Pyrite? I don't know what Pyrite is, actually. Oh, it's a static type checker for Python. Okay. It's a static type checker. Well, so again, the problem is that this couldn't be solved statically to the full extent. It needs the dynamic factor, because statically you cannot solve all potential cases. Like one example is you have, let's assume you have class A, and this class A has like some method, ASDF, which does something. And then you have class B, which actually is inheriting over A, and you have the same method, but it does something else. And then we have class C. Sorry, and then we have class C, which does the same. And now let's assume that we are inspecting a function, which is called xyz, which actually expects A to be A, right? And then we do ASDF. And we cannot really answer the question which of these methods is going to be called here, because all three are acceptable under the static typing definition. What we could only do is at runtime, we could say, oh, actually A is of type C, so we know that this is what's going to be called. Yeah, it's a hard problem. It's a hard problem. Cool. Something to think about. Is it faster to write a fuzzer? A good question. A fuzzer wouldn't be able to... So the problem, okay, it's like this. A fuzzer would be able to cover for potentially all the calls of a function with all parameters, or maybe, you know, just like choose and pick, right? You cannot cover the whole space, it's just impossible, but you can do some smart fuzzing and select like some parameter values, which would cover quite a lot. What would make it harder for a fuzzer is for the environmental factors, if you will. For example, if you have a code which does, I don't know, connects to the network, right? Then you can have so many weird exceptions due to what happened on the network while trying to connect, that a fuzzer would not find them all unless you would really well simulate all the possible scenarios. And to simulate all the possible scenarios, you'd basically have to dig so deep into the code that you would just like be easier just reading the exception list from the code. Okay. Yeah, I think we are going to end it here. In that case, I am quite unhappy with the amount of edge cases we found, because this makes it a little bit harder than I imagined. And that's good. That's good, because that gives me a little bit more subjects, like food for thought, if you will. And it will, I guess I will think about it another year or two, and I will go back to it if I have a good idea how to perhaps solve the issues. So I guess like the next live stream is going to be something else. I'm kind of playing with an idea of maybe making a video about the whole FFmpeg versus Google drama, but still only playing with it. If you have any comment on that, feel free to leave it in the comments or in the chat. Yeah, Johnny has like a really good comment that at least that explains why it's not already a thing. Yeah, that is true. I think like in Java, they had an idea that you declared all the exceptions that a function could throw, and you had to catch all the other exceptions. And I think that was a solution to the problem, because as long as the declarations are accurate, and as long as the compiler actually checks you, then that would solve the problem, which is like missing from Python. Python doesn't really have a way to decorate the functions to say, oh, this function can throw this exception, that function can throw that exception. Is it super needed? Yeah, probably no. Like, yeah, stuff will crash, but that's kind of expected, right? I guess that's what we can say. Cool. So that's it for tonight. I wish you a pleasant evening, and I'll see you, I don't know, probably next week, because I have 2 live streams in Polish, 2 workshops actually next week, so I will probably want to do something in English as well. Thank you very much for being here and helping me think about this problem, and again, have a great rest of your weekend and see you next week. Bye bye.